Nearly 1,000 years ago, in 1054, a remarkable celestial event unfolded before the eyes of humanity. A new star suddenly blazed in the sky, an unexpected beacon of light piercing the darkness. It was so bright, in fact, that it was visible even during the day, a truly extraordinary sight that captivated observers across the globe. Ancient Chinese astronomers meticulously recorded its appearance and gradual fading, noting its position and brightness with careful precision. Little did they know, they were witnessing a supernova, the explosive death of a massive star, a cataclysmic event on a cosmic scale. But this star's story didn't end with its brilliant flash. Its legacy would continue to unfold across the vast expanse of space and time. Its violent demise left behind the Crab Nebula, a testament to the star's dramatic end. This is a glowing, expanding cloud of gas and dust, stretching 6 light-years across, a vibrant and ever-changing canvas in the cosmos. For centuries it was a faint smudge in telescopes, a barely perceptible glimmer for early astronomers. But today, with advanced technology, we know it as one of the most dynamic objects in our galaxy, a powerhouse of energy and activity. The Crab Nebula is a cosmic laboratory, a place where scientists can study the extreme conditions created by a supernova. It represents the aftermath of a star at least 8 times the mass of our Sun, a giant that lived fast and died hard. When such a star dies, its core collapses in on itself with unimaginable force, triggering an explosion of unparalleled magnitude. This explosion hurls its outer layers into space at tremendous speeds, creating the intricate filaments we see today, a beautiful and chaotic display. These filaments are rich in heavy elements, forged in the heart of the star and scattered across the cosmos, the very building blocks of planets and life as we know it. Looking at the Crab Nebula is like peering back in time, witnessing an event that occurred millennia ago. The light we see began its journey 6,500 years ago, traveling across vast distances to reach our eyes. It's a living snapshot of stellar death and rebirth, a continuous cycle that shapes the universe. It's a reminder of the universe's endless cycle of creation and destruction, a process that has been ongoing for billions of years. The Crab Nebula connects us to a cosmic event witnessed by our ancestors, bridging the gap between the past and the present. It's a powerful reminder of our place in the universe, linking our story to the grand narrative of the cosmos. It's a ghost in the sky, a haunting reminder of the star that once was. It's still teaching us about beauty, violence, and the enduring energy of the cosmos, a testament to the power and wonder of the universe. For centuries, our view of the universe was flat stunning, but two-dimensional. Even the most beautiful telescope images are just cosmic postcards lacking depth. NASA's Universe of Learning program changed that by building a fully immersive, three-dimensional model of the Crab Nebula. This isn't just an artist's impression, it's a scientifically accurate reconstruction, letting us fly through the nebula and see its true structure from every angle. Scientists combined data from multiple observatories, piecing together layers of gas, dust, and high-energy particles like cosmic archaeologists. The result? A digital journey that transforms our understanding, turning flat images into a visceral, navigable experience. For scientists, it's a powerful tool to test theories. For the rest of us, it's a way to connect with the universe in a whole new dimension. This leap into 3 dimensions is changing how we see and explore the cosmos. To truly understand the Crab Nebula, a celestial tapestry woven from the remnants of a supernova, we need more than one telescope. One perspective simply isn't enough to capture its full grandeur and complexity. We need a symphony of eyes across the electromagnetic spectrum, each attuned to a different wavelength of light, revealing hidden aspects of this cosmic marvel. NASA orchestrated observations from 3 of its great observatories, a trio of space-based telescopes designed to peer into the universe in fundamentally different ways. Hubble, with its unparalleled clarity and visible light. Spitzer, sensitive to the infrared glow of heat and dust. And Chandra, which captures the high-energy X-rays emitted by the most extreme environments. Hubble captures the nebula in visible light, providing a familiar and stunning view, revealing intricate filaments of glowing gas, delicate structures sculpted by the supernova explosion. These filaments are the star's outer layers, ejected into space and now glowing brightly, rich in elements like oxygen. Spitzer sees in infrared, piercing through the dust to map the distribution of cosmic dust, and revealing the ghostly glow of synchrotron radiation, a telltale sign of energetic particles. This radiation is light emitted from electrons spiraling around powerful magnetic fields, a process that dominates the nebula's energy output. This infrared view shows the nebula's interior, a region normally obscured by dust and visible light. It highlights where the central engine's influence is strongest, the source of the nebula's power. Chandra, tuned to X-rays, reveals the nebula's ferocious heart, a region of intense activity and extreme temperatures. At the very center lies a rapidly spinning neutron star, or pulsar, the collapsed core of the original star. Chandra's data shows a brilliant ring of superheated material, a shockwave created by the pulsar's energetic wind, and powerful jets blasting from the pulsar's poles, streams of particles accelerated to near the speed of light. Each observatory reveals a different layer of the nebula's story, a unique perspective on its complex structure and dynamics. By combining their views, we get a complete, multi-layered picture of the Crab Nebula's structure and energy, a holistic understanding that would be impossible to achieve with a single instrument. This multi-wavelength approach is essential for unraveling the nebula's complexity, allowing us to piece together the puzzle of its origin and evolution. It's a cosmic collaboration that lets us see what no single telescope could reveal alone, a testament to the power of teamwork in scientific discovery. The Crab Nebula's true nature emerges only when we see it through all these eyes, a symphony of observations, revealing the beauty and power of the universe. By merging data from the Hubble Space Telescope, the Spitzer Space Telescope, and the Chandra X-ray Observatory, we gain an unprecedented view into the cosmos. This powerful combination allows us to dissect celestial objects in ways never before imagined. We can peel back the Crab Nebula's layers, like examining the intricate workings of a complex machine, and see how its individual parts interact and contribute to the whole. Hubble's visible light data, rendered here as yellow, reveals the nebula's intricate skeleton, a framework of light and shadow. It showcases vast, branching filaments of gas, the scattered remnants of the star's explosive demise. These are the very building blocks of the nebula. These filaments are not uniform, they are clumpy and turbulent, swirling with energy. They are forged from elements essential for life, created in the heart of the dying star and scattered across the cosmos. Spitzer's infrared view, represented in red hues, fills the interior with a ghostly glow, revealing hidden structures invisible to the naked eye. This glow is caused by synchrotron radiation emitted from energetic electrons as they spiral along magnetic field lines. This layer effectively maps the nebula's complex magnetic influence, revealing its underlying structure. It also highlights the presence of clouds of dust, further adding to the intricate and complex structure of the nebula. Chandra's X-ray data, depicted in blue, precisely pinpoints the location of the pulsar at the very heart of the nebula. This pulsar is a tiny, rapidly spinning dot of unimaginable density, a neutron star born from the supernova. Surrounding the pulsar, we see a bright ring of highly energetic material, a testament to its immense power. From the pulsar's poles, two powerful jets of particles blast into space at nearly half the speed of light, shaping the surrounding environment. Each wavelength provides a unique and invaluable piece of the puzzle, telling a distinct part of the overall story. The filaments illuminated by visible light, the intricate magnetic web revealed in infrared, and the pulsar's raw, high-energy power unveiled in X-rays. When combined, they reveal the Crab Nebula not as a static object, but as a dynamic, living, multi-layered system constantly evolving. The three-dimensional model allows us to examine these layers both separately, to understand their individual contributions, and as a unified whole. This process transforms potential confusion into clarity, allowing for a deeper understanding of complex astronomical data. It's akin to observing the skeleton, circulatory system, and nervous system of a cosmic creature, all working in harmony. We can see them all at once, gaining a complete and integrated view. This layered analysis is absolutely key to unlocking a deeper scientific understanding of the Crab Nebula and revealing its true nature. Most supernova remnants are simple, fading shells of gas. The Crab Nebula is different, a pulsar wind nebula, powered by a central engine. Instead of a black hole or scattered debris, the Crab's core became a neutron star, a city-sized sphere with more mass than our sun. This neutron star is a pulsar, spinning rapidly and generating a powerful magnetic field. The pulsar acts as a cosmic dynamo, pumping energy into the surrounding cloud. Its wind is a torrent of high-energy particles, not air, but electrons and positrons moving near light speed. This wind collides with the slower supernova debris, creating shockwaves and keeping the nebula shining across the spectrum. The outer filaments are the old embers, the interior glow is powered by the pulsar's relentless energy. The Crab Nebula is a living system, not a fading ghost. Its heart still beats. At the Crab Nebula's center lies the Crab Pulsar, one of the universe's most extreme objects. It's a neutron star, a sphere just 20 kilometers wide yet heavier than our Sun. A teaspoon of its material would weigh billions of tons. The Crab Pulsar spins 30 times per second, its magnetic field trillions of times stronger than Earth's. As it spins, it sweeps beams of radiation across space. If one crosses Earth, we see a pulse. This spinning dynamo rips particles from its surface, accelerating them to near light speed and creating the pulsar wind. The jets and bright rings seen in X-rays are direct results of this furious engine. The pulsar radiates more energy every second than our Sun does in 100,000 years. This power inflates the nebula, making it glow brightly even centuries after the explosion. Without the pulsar, the Crab Nebula would have faded long ago. Its heart is what keeps it alive. The new three-dimensional model of the Crab Nebula is more than a visual upgrade. It's a scientific breakthrough. For decades, astronomers guessed at the nebula's true shape from flat images. Now, we can see the X-ray ring as a torus, with jets blasting out perpendicular. Classic signs of a pulsar wind nebula. The 3D view shows how the high-energy bubble sits inside the cage of cooler filaments, confirming long-held theories. Scientists can now study how jets bend and interact with surrounding material, revealing new physics. Moving from 2 dimensions to 3 replaces guesswork with observation, making models more accurate. This approach isn't just for the crab. It's a new tool for exploring all kinds of cosmic objects. We're finally seeing the universe as it truly is, vast, deep, and interconnected. This 3-dimensional journey into the Crab Nebula is a triumph of collaboration. Scientists, engineers, and visualization experts from NASA's Universe of Learning program joined forces, combining data from Chandra, Hubble, and Spitzer. Each team brought unique expertise, X-rays, visible light, infrared, to build a complete picture. They aligned and calibrated their data, turning raw numbers into a compelling, accessible visual story. This project bridges research and public outreach, making cutting-edge science available to everyone. Tools like this visualization inspire students and lifelong learners, democratizing access to the cosmos. It's a reminder that science is a shared human endeavor, made stronger by teamwork. Together we can see farther and understand more than any one person or telescope could alone. The Crab Nebula is a cornerstone of astronomy, one of our closest, most studied supernova remnants. Its precise age, anchored by ancient records, lets us test our models and measure its expansion. The new 3D view confirms its nested structure and reveals the true geometry of its central engine. The crab serves as a Rosetta Stone for understanding other pulsar wind nebulae. Seeing the tiny pulsar powering a structure trillions of kilometers across makes the science tangible. This visualization builds intuitive understanding, connecting us to the cosmic processes that shape our universe. The Crab Nebula is a nearby laboratory for the biggest questions. Where do elements come from? How do stars die? What forces shape the cosmos? The ghost of a star that once lit our skies continues to illuminate our understanding, its legacy shining brighter than ever.